right, good morning, everybody. So quick announcement, there's a quiz next week on Wednesday, I think, in this course. I think it's Wednesday. The quiz is going to work the same way as quiz 1. It'll be roughly the same length as quiz 1. There is a sample quiz or last year's quiz, I guess, on OnQ that you can look at. And it covers up to implementing equals. Right? So you don't need to know comparative or hash code. It's just up to equals. You can kind of guess what's going to be on the quiz, right? You're going to have to implement a class or classes. There's probably going to be an equals method in at least one of the questions, right? So you'll need to understand constructors. You'll have to understand that objects have, classes that make objects have fields, and so on and so on and so forth, right? It's not terribly difficult to guess what could be on this quiz. The topic of today's lecture is enumerated types, so the enums, which you've already seen on at least the first assignment, the first and second assignment, I guess, in the course. You'll see it again on the next assignment, which comes out hopefully this afternoon. If not this afternoon, it'll come out tomorrow. So the enumerated types are, they're a reference type. So you use them in Java when you want to represent a group of constants that are all related to one another. Right? So for example, days of the week, right, the months of the year. If you're implementing a playing card class, right, you have the ranks and suits of the cards, right? Arithmetic operations, there's a constant number. There's a fixed number of arithmetic operations that you can perform on numbers, right? So you can even represent these using an enumerated type, right? These things have some certain characteristics in common, right? So there's all a fixed number of these things, right? 7 days of the week, right? 12 months of the year, right? That number never changes or changes very, very rarely, right? They're all constant, right? Monday is always Monday, right? Tuesday is always Tuesday, and so on and so on and so forth. So the enumerated types, they're types that represent the values consist of a fixed set of constant values. Right? So if you have something that you want, if you have objects that you want their state to change, you're not using enumerated types. You're using just regular classes. Okay, so older Java code. So this is before Java, I forget which version, version 5, I think. And the predecessor language to Java, which is called C, did not have built-in enumerated types. And so what you would do is if you had a bunch of constants, a bunch of related constants, you would do something like the following. You would use ints to represent the individual constants. Right? Now in Java, of course, if you want a constant int, you make it static and final. Right? So you'd say Sunday is equal to, for example, 0, Monday is 1, and Tuesday is 2. Right? You give each day a different integer value. Right? The value may or may not have some meaning. Right? It's just meant to, but they need to have different values so that you can distinguish between Sunday and Monday, for example. Right? For the months, you would do January, February, March. Right? Again, assigning them some integer value. So this sort of works. I mean, it serves the purpose of defining some constants. Right? These values are all, in fact, constant. They all have unique names. Right? So that's nice. But there's a lot of disadvantages. Right? So the biggest disadvantage in this case is that there's no type safety. Right? Everything's just an int. All your constants are int. Right? So if you can imagine any method that accepts an int as one of its parameters, it now accepts a day or a month. Right? So for example, you can do things like perform arithmetic with days and months. Right? You can call math.square root with January, and you get the square root of January, which logically doesn't make any sense, but it works. Right? You can do addition, multiplication, subtraction. Right? You can compare things. Right? If you write a method, and that method is supposed to only take in a month, right? There's no way to write that method. Right? It has to take in an int because your types are ints. Right? And now you have the problem of any method that you write, which is only supposed to accept months, it now has to validate the input. Right? It has to check, is the month less than, is it between 0 and 11? right? If it's not, then it's not a valid month. Right? So you've got all this validation code kicking around all over the place, right? And you can do a bunch of things with months or days of the week that you logically should not be able to do. Now, one of the advantages is if you want to test is a day actually Monday, that test is very fast, right? Because you're comparing two int values, right? So Sunday equal to Tuesday, no, 0 is not equal to 2. Comparing two ints is very fast. So that's at least one advantage, right? There's other disadvantages as well, right? So for example, if I wanted to print out the string Sunday, right, when you, for the day or for the constant representing Sunday, to do that. ToString method for months or days, right? You have to write some method on your own that takes in a month, interprets the value of the month as, and then prints out the appropriate string, right? So there's no good way to automatically convert a constant to a string, right? Also inconvenient. You can get around that last problem by using strings instead of ints, right? So instead of using int Sunday equals 0, you can use the string Sunday and give it some constant string, right? This works in Java because strings are immutable, right? So making a static final string called Sunday, it really is the string all caps Sunday, right? Of course, you can use different strings over here. They don't have to match the name here. So this gets around the last problem. I can print Sunday very easily because it's just a string, right? So just system.out.println, all caps Sunday, and you get the string Sunday. So that avoids the last problem, but it doesn't avoid the other problems of type related to type safety, right? So everything's a string now, so I can pass a month to any method that accepts a string, right? Also, programmers are lazy. So instead of writing something like the month.Sunday, which is what you have, instead of writing the class name.Sunday, right, programmers will just start writing Sunday everywhere in their code, right? And that creates a problem if, for example, you decide later on you have to change the value of that string. Now you have to go into your code and change every occurrence of Sunday, right, which is also annoying and error-prone. There's another problem, right, which a lot of programmers often overlook, right, especially today, or especially in modern times, because computers are so fast now. But if you want to compare two strings for equality, right, that's not a fast operation, right? So if I wanted to compare, for example, two strings representing days, potentially you have to look at every character in the string to determine if they're equal, right? So to determine if Sunday equals Sunday, I have to compare 6 characters. Right? Using the old int style enumerations, you just compare one int, right? Now that doesn't sound like it's such a big deal, right? 6 comparisons versus 1. But if your constants become very long, if the length of the constant becomes very long, now there could actually be a noticeable amount of time that's needed just to compare whether or not 2 constants are equal, right? So that's no good, right? That's not really desirable. Okay, so it is version 5 of the language that added a dedicated enumeration type. So in the package lang, there's a class called enum. When you make an enumeration, you are implicitly inheriting from this class here, right? So whether or not you say it, you end up inheriting from enum. Enum inherits from object. Right? Now enumerations, they are proper classes, right? And so that means you can have fields. Right? So you can actually store data in your enumerations. Right? You can have methods that operate on enumeration objects. You can even have constructors, but the constructors are funny for enumerations. Right? All your constructors are private for the enumerations. It's really easy to make one of these enumerated types. It's even easier than using the int or string enum pattern. Right? All you have to do is make a little class called a class that's enum instead of class. It's still a class, but it's a special type of class. Right? So public enum, the name of your type. So in this case, I'm going to call it day, and then you just list the constants that you want. Right? So what this does here is it creates a constant day object called Sunday. Right? It creates a constant day object called Monday. It creates a constant day object called Tuesday, and so on and so on and so forth. What this actually does is it makes exactly 7 objects whose type is day. Right? The name of the 7 objects are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Right? And so there's only ever exactly 7 day objects in your program. Right? So there's not 2 objects that are equal to Sunday. Right? There's only 1 Sunday object, there's only 1 Monday object, and so on and so on and so forth. Right? So it's really easy to use these things. I mean, you used them in assignment 1 when you didn't even really know Java. Right? If I want the constant Thursday, you just write day.Thursday. If you want to print it out, you just print out D and you get Thursday. Right? So the enumerations, they give you built-in toString method. If you want, you can change it. Right? So you can overload toString in your back here. Right? So you can add in an override of toString and change the string that gets printed depending on which day it is. Right? So this is what I mentioned 2 slides ago. When you make an enumerated type, you get exactly 1 object for each of your constants. Right? Now, you only have 1 object for each of your constants, and that means when you compare two enumeration constants, you can use equals equals or not equals. Right? So even though it's a reference type, you can safely use equals equals or not equals to compare them. If you want to, you can use equals. That's fine too. Right? So you don't have to worry about the difference between that and that. Right? And that works because there's exactly 1 object of each constant, representing each constant. Right? Now the reason, so you are allowed to have constructors in your enumeration, but the constructors are private. And so what that does is it prevents anybody else outside of the enumeration from making a new constant value. Right? And so that guarantees that there's exactly, in this case, that guarantees that there will only ever be 7 day objects. Right? You can't make, nobody else can make a new day object because they don't have access to the constructor. Enumerations are proper types, right? So they are classes. And that means they have a proper type. They're a reference type. And that means you get all the benefits of compile time safety or type safety. Right? So imagine we have our second enumeration called month of the year. Oops, sorry. There's supposed to be there's a missing slide. Right? You can now make a method that takes in a day and does something with the day. If you try to pass it a month object, it fails, right? The compiler won't compile your code, right? The method needs a day. If you try to pass it February, that's a month. Now it no longer works, right? So that gives you your type safety here, right? Which is a big benefit compared to the int or string style enumerations. You even get comparable for free. So you can compare 2 objects of your enumerated type for order. Right? Now, this is a little bit limiting. So the only way that you can compare 2 of your types for order is the way in which you wrote the constants out when you made your class. Right? So for example, back here, right? The way compare 2 works for months is that this is the smallest month. That's the biggest month. Right? February is the 2nd smallest month. November is the 2nd largest month, and so on and so on and so forth. Right? There's no way for you to change the behavior of compare 2 in this case. Right? So you cannot replace the definition of compare 2 in your enumeration. Okay, so if you want to compare 2 days, right, this is how you do it. Right? I've got Monday, Thursday, and Saturday. Right? If I want to compare Monday to Thursday, Monday comes before Thursday, so it's smaller than Thursday. Right? So you get back a negative number. It's 3 days smaller than Thursday, so you get back -3. Right? So the return value by compare 2 tells you the difference in the positions of your two constants. Right? D2 compared to D2, so Thursday compared to Thursday, well, it's the same day, so it's 0. D3 compared to D1, so Saturday comes after Monday. So it's bigger than Monday, and it's bigger than Monday by 5 days. Was there a question over here? Do you have a question? No? Okay. I thought I saw a hand up. All right, now unlike just using a plain old string or an int, you are allowed to have fields inside for your enumerated types. Right? Your fields are initialized by a constructor, but the syntax is a little bit strange here. Don't forget, the constructors for your enums are always private. Right? And so also don't forget that your enumerations are supposed to be constants. Right? You're allowed to have fields. Technically, the field value for one of your constants can change, but you're not supposed to do that, right? Your enumerated types are supposed to represent constants. You should avoid changing the value of a field belonging to an enumerated type. Okay, so if you wanted to include fields in your type, you somehow have to initialize the field, which you're going to do via a constructor. The way you call the constructor is, after the name of your constant, you put in the round brackets, and then you put in the arguments to your constructor. So for the month type, I'm going to initialize each month to the number of days in that month. Right? February is a bit of an odd one, right, because of leap years. So January has 31 days. February, by default, normally has 28 days. Right? March has 31 days, and so on and so on and so forth. Now you add your field. So the field I'm going to use to represent the days in the month is called days. Right? This type is int. It's supposed to be a constant, so I'm going to mark it final, but there is no requirement that it actually be final. I'm going to make it private to make sure that nobody else can see that value directly. Or, well, they can't change it because it's final, but I'm also going to mark it private. Now you add your constructor. Right? So our constructors have always been public. In an enumeration, your constructors are always private. Right? You're not allowed to make them public. If you put in anything except for private or nothing, the compiler will complain. Right? So if you put in nothing, the compiler automatically makes it private. You can put in private explicitly yourself if you like. Right? So I have a constructor month. I have a constructor for the month type, takes in the number of days. All it does is set this day is equal to days. Right? And away you go. Now, it's a type, right? It's a class. So you can add methods. Right? So I can provide a method that returns the number of days for a given month. I have to account for February and leap years, so unfortunately I have to pass in the year to this method. Right? So it's non-static, right? So you're going to call it with a month object, right? So m.days, right? If m is not February, so if this is not February, I can just return the value that's sitting in the field. Right? I can use not equals, so exclamation mark equals to compare this object, the object that was used to call the method, right, to the constant February. Right? Again, if you want to, you can write exclamation mark this dot equals February, right? But you can safely use equals equals and not equals here. Right? Now I have a little bit of logic here that tests if the year is a leap year, and if it is, it returns the number of days plus 1, because this is the number of days for February. Right? Otherwise, we just return this dot days down here. And yes, you could write this method in a different way. Right? But you have to account for the leap year in some way. Right? So it's just a regular class. Right? It can have fields, it can have methods. The only thing you have to remember is that the constructor is private. You get a bunch of other free things as well when you make an enumerated type. Right? So you get a method called values. It's static. Right? Values returns an array of your constants in the order that you declare them in, right? So if I want to know what are all the constants in the enumerated type month, you just call values on month, right? So month.values, that gives you an array. I can print the array using arrays to string, and you get back the array of all the constants in the order that they were declared, right? So I get back the array January through December. Right? So that lets you do things like iterate over all the months. Right? So for each month m, in month.values, right, all of the different months, right, I can do something with that month object m. Right? So for example, I can print out the month followed by the number of days in that month for the year 2018, right, which prints out that. Right? So now you can iterate over all of your enumeration constants nice and easily. Notice there's no way for you to do that if you're using plain old ints or plain old strings to represent your constants, right? The only way you can do that is if you take your ints or strings and stick them into a list or an array somewhere, right? But the values method does that for you automatically. Right? What else do you get? You get value of, right? So you get a static method called value of that lets you convert a string to one of your constants. That's also pretty handy, right? So I would like to know, what is the value of? I would like the month object corresponding to the string all caps May, right? So month.value of May gives you back the month May, right? You can test if they're equal, and they are. Right? So this lets you automatically convert strings to their corresponding enumeration constant. Right? The string that you pass in here matches the name of the constant. All right, so they're just classes, so you can add your own methods, right? But it gets even fancier than that, right? Each one of your constants can have its own version of a particular method, right? So the month, for example, the month January can have a different method, where's days? There's a different way to implement this, right? So the month January can have a different version of this method than the month February, and so on and so on and so forth, right? Each constant can have its own version of a method, which is really unusual, right? That's very unusual. You haven't seen anything like that at all in this course yet. Right? Now to do this, if you want to do this, what you do is you declare what's called an abstract method in your class, right, in the enumeration. Now an abstract method is sort of like, an abstract method is a method that has no implementation, right? So you get it's just the method header, right? So it's the same thing as having a method in an interface, right? Remember, in an interface, all the methods have no implementations, right? They are all examples of abstract methods. So here's an example. I pulled this out of this book, Effective Java, that implements a very simple calculator in like a few lines of code using enumerations. Right? So this is a calculator that can add, subtract, multiply, and divide. Right? So you make an enumeration called operation. Right? So this operation is an enumeration that represents addition, subtraction, multiplication, and division. Right? Now, when you add two values, right, you want to do x plus y. When you subtract two values, you want to do x minus y. Multiply two values, x times y. Right? Divide two values, it's x divided by y. Right? So for each one of your constants, right, you can define a method called apply. Right? Apply simply applies this operation to these two values. Right? So apply xy for plus, adds x and y. Right? Apply xy for minus, subtracts x and y, and so on and so on and so forth. Right? To indicate that your type actually has an apply method, right, you make a public method, you declare it to be abstract, right? You give it a name, you give it the parameters and a return value, right? And now anybody using your class knows that there's an apply method, right? When they call apply using one of your constants, they get a specialized version of apply, right? So that's really, that's a really interesting idea, right? That's not something that we've seen yet in this course, right? Different objects can have their, different objects of what seem to be the same type can have their own method, right? Can have their own version of the method. All right, so exactly when should you use an enumeration, right? So there's a common, what's the word I'm looking for? There's a common occurrence when you're programming, right? So you'll often have a method where you'll want to do one of two things, right? Depending on the value that's passed into the method. Right? So often what will happen is, often a programmer will implement such a method by passing in a Boolean value. Right? So for example, this is a constructor. These are both constructors, for example. Right? So imagine you have a class called binary digit. Right? This represents binary digits, right? So zeros and ones. Right? That's the constructor, so I'd like to initialize the binary digit to 0 or 1. right? Now you can say, well, Boolean values represent one of two values, so I can write Boolean value, right? If value is true, presumably you get a binary digit that's 1. If Boolean is false, presumably you get a binary digit that's 0, right? Imagine you're implementing a class that represents a thermometer, right? That can measure temperatures in Celsius or Fahrenheit. Right? To indicate the temperature scale, you could use a Boolean variable, Boolean parameter, sorry, called scale. Right? If scale is true, you get a thermometer that measures in degrees Celsius. If scale is false, you get one that measures in Fahrenheit. Right? Now the problem is when you write code using these, right, you end up writing something like new binary digit true, new binary digit false, new thermometer true, new thermometer false. And if you just look at that piece of code, you have no idea what's going on, right? Until you go and look up the documentation for the constructor, right? Whereas if you used enumeration constant, if you used enumerations to represent 1 and 0, or Celsius and Fahrenheit, there's no doubt about what's happening here, right? That's a new binary digit whose value is 1. That's a new binary digit whose value is 0. Right? That's a thermometer that measures in Celsius. That's a thermometer that measures in Fahrenheit. Right? It's absolutely crystal clear what's going on here, right? As opposed to thermometer true, thermometer false. So using enumeration constants makes your code much easier to read. Makes it harder to write, right? Notice you got to write a lot of stuff here, right, to indicate that you wanted a thermometer in degrees Celsius, right? But later on, it's much easier to read. Okay, so when else should you use an enumeration constant? So when else should you use an enumeration? So if you have a group of constants that are related to one another, the number of constants is fixed and you know what they are ahead of time, then you should use you should consider using an enumeration. Right? So this mentions the card class, which it only makes sense if you're reading the notebooks for the course. So inside the notebooks, there's a card class that represents a playing card, standard playing card, right? So the 4 suits, hearts, diamonds, spades, and clubs, and then the 13 cards, right? So 2 through 10, Jack, King, Queen, Ace, right? So one of the ways to implement the card class is to use a string. I don't have it here. Is to use a string for everything. Let me just quickly check if I have it in the class. Is it here? It is not. Sorry, I don't have it here, which is unfortunate. Right? So one of the ways to implement this class is to use a string for everything, right? The string hearts, diamonds, clubs, and spades for the suits, and then a string for the value of the card, right? This is one example where it's much easier to write the class if you use enumerations for the suits and enumerations for the values, right? If you use a string, you've got to validate the string every time, right? So you have a method you have a constructor that builds a card given 2 strings. You have to test, is this string one of the suits? You have to test, is the string one of the values, right? If it's not, you throw an exception. It's a real pain in the butt, right? If you use an enumeration for the suits, there's only 4 suits, right? You don't have to validate the enumeration. Right? There's only 13 values. Again, if you use an enumeration for the values, you don't have to validate the values. Right? It saves you a lot of work in the long run. All right, so that's all I want to say about enumerations. They're not super common in code, so it's not very often that you're making them. But when you want to use one, they become very convenient. Right? On the next assignment that comes out, there's 2 small enumerations that you can use in your assignment. All right, anybody have any questions about enumeration? Yes?
In the example, for when you wanted to use enumerators instead of Boolean parameters,
Yep.
when you're defining temperature scale, for example, would you ever add information to that, or is the whole idea just to have them in Celsius and Fahrenheit?
You could. I mean, so it really depends on what you want to do with the thermometer and what you want to do with these constants. But yeah, you could add methods to the enumerations, right? So you could add a method to the temperature scale enumeration that can convert between Celsius and Fahrenheit, for example, right? So yeah, that would be a sensible place to put that kind of information. Yeah, or that kind of functionality. Yeah. Right, you can even Actually, I don't know if that's true. I was going to say you could even put constants related to the temperatures inside the enumeration. I'm not 100% sure that's true. I'll have to try that later on. But you could put things in. So, for example, if you were really making it a real temperature scale class, right, you would include Kelvin and other things as well, right? So you might put in the notion of absolute zero somewhere as a constant. I think you can do it. I think you can make a public static constant inside of enumeration. But yeah, it's just a regular class, so it should be doable. All right, any other questions? Super. Whether they told you this or not, there are enumerations in Python as well. Right? The Python enumerations have similar functionality to the Java ones. All right, so we're at 10. Okay, so I guess we should start the next lecture. The next lecture is a bit awkward because this lecture tends to change from year to year depending on what we're doing in the course. And I have not updated this set of slides. So you're going to see stuff that you haven't seen before. All right, so the next part of the course, you now know how to make a basic class, right? And enumerations, I guess. The next part of the course deals with making classes that are related to or use other classes. Right? So now we're going to look at the structure of a class. And to talk about the structure or relationship between classes, right, we're going to use something called a UML class diagram. So UML, I've mentioned before, is the Unified Modeling Language. It's a visual modeling language. It was originally designed to, I think it was originally designed to describe object-oriented programs. It's now used for a bunch of other things as well. It's very common in software engineering. It's used to visualize the design of a software system. So that diagram there is a UML class diagram that describes the UML language. Right? So you can see here up at the top, there's this thing called diagram. Right? So everything in a UML diagram is an instance of this class called diagram. Right? There's a thing called a structure diagram and a behavior diagram. Right? Structure diagram describes the structure of a class or an object. Right? A behavior diagram describes how a class interacts with how objects interact with other objects. Right? We don't care about the left side of this picture. Right? What we care about is, we only care about one thing, actually. We care about this thing right here, the class diagram. So the class diagram is a structure diagram, which is just a regular diagram, which is also a diagram. Right? The class diagram describes the structure of a class. Right? So in other words, it describes what fields a class has and what methods a class has. Right? So you describe the fields and you describe the methods. Now in UML, it's not designed for any particular object-oriented language, so it uses generic names for things. Right? So in Java, we call variables that belong to a class, variables that belong to an object fields. Right? UML uses the word attributes. Right? In Java, we call our functions or procedures methods. UML uses the term operations. Right? That's a UML class diagram. Pretty easy, right? Everybody can draw that, right? So if I wanted to describe the point2 class, you just draw a box and write point2 in it. Right? That's the simplest example of a class diagram. Right? The name of the class is the only mandatory information. Right? This is meant to be a visual language, so you're supposed to do things in a standardized way. Right? So the name of the class is supposed to be centered in the box. Right? If you want to, you can add extra information. Right? So if your class has fields, you can add those fields to the class diagram. You don't have to add all the fields. You can just put in a subset of fields if those are the only ones that are important for the particular diagram that you're drawing. Right? So the way this works is there's an access modifier, there's the name of the field, there's a colon, and then there's the type of the field. Right? So again, it's not designed for any particular object-oriented language. Right? So it specifies these features in its own way. Right? This means private. That's the type. Right? Again, it's a visual modeling language, so everything's supposed to be written in a standardized way. This stuff's supposed to be left justified. For your access modifiers, you use minus for private, you use plus for public. There's the tilde for package private, and there is the hashtag for protected. Right? Don't bother memorizing this, right? You really only need to know plus and minus. Now, if you want to, you can also put in the methods of the class, right? So you write them in another box below the fields, assuming the fields are there. Right. I'm just going to show you an example, right? So here are my constructors, right? Again, there's an access modifier, so plus means public, right? For the constructors, it's just the name of the constructor followed by round brackets. If your constructor has parameters, then it's the name of the parameter, colon, type, right? So X is a double. Right. For our copy constructor, our parameter is called other, its type is 0.2. Right? It's the same thing for the methods. Right? Method, access modifier, method name, parameter list. If your method returns a value, then after all of that, it's colon followed by the return value. Right? So there's a method X that returns a double. There's a public method Y that returns a double. There's another public method X that returns a 0.2 reference. Right? The input is a double value. Right? Equals is public, right? Returns a Boolean, has one parameter of type object. Right? And so what this gives you is a very concise description of a class. Right? It doesn't give you all of the it doesn't give you all the details, right? So it doesn't explain what each one of these methods does. It doesn't explain the purpose of the fields, right? It simply describes the structure of your class. Right, so this is a very, very efficient way to communicate what a class looks like, right, without having to write out the entire class. So as I mentioned before, this lecture is a bit awkward. So this is from a previous year. We looked at this. We looked at a class called PPM ASCII Reader that can read in a particular type of image file. Right, so you don't actually have to understand what's going on here, right? You just have to understand what the diagram is trying to tell you. Right? It looks like there are 5 fields. Right? It looks like there's a field called magic number that's private, that happens to be a string, so on and so on and so forth. Right? There's a method called image. It's public. It returns a simple image. Right? Right? So even without knowing what this thing is supposed to do, right, you can quickly look at this picture and say, oh yeah, this is, you can quickly look at this picture and determine the structure of a PPM ASCII reader object. If your class implements an interface, then you can indicate that on your diagram as well. Right? So one way to do that is with what's called the lollipop notation. So point 2, we've now implemented the Okay, so if you want to indicate that on your UML class diagram, you just attach this little line and circle to your class, indicate the interface that you're implementing. Again, so I guess in the winter term, there was a class called ranged value that also implemented comparable. Right? All right, so that's the very quick and dirty introduction to a UML class diagram. If you go on to take some of the software engineering courses later on, you're going to run into these diagrams again. Yeah? So, oh no, you can put this wherever you want, wherever it fits. Right? So what you have to remember is this is, you can have very large UML class diagrams when you start to describe how objects interact in your program. Right? So you're going to have a class diagram for each one of your objects. So for each one of your object types. So in a large program, you might have one of these diagrams that have like hundreds of these squares flying around all over the place. So you just stick in where, you just put in that thing wherever it fits. Exactly where it goes doesn't matter. All right, so we now want to talk about relationships between classes. So what happens when you build, what happens when you make a class and it has fields that are also of reference type? Right? Because you now have a relationship between a class that's inside of another class. So in any non-trivial object-oriented program, right, it's going to be made up of multiple classes. They all interact with one another, right? You've got several classes. You make objects with the classes. The objects interact. The relationship between the classes is important, right? So classes that are built using other classes, their structure is related to one another. Right? Classes that interact with other classes, well, that describes the behavior of the classes in your program. Right? We're only interested in the structure in this course. We're not interested in the behavior so much. Okay, so what kinds of structural relationships can you have between classes? Right? So the weakest relationship that you can have between two classes is called dependency. Right? So dependency models what's called the uses relationship. Right? So if one class X uses a second class Y, then we say that X depends on Y. Why is the Y missing? X depends on Y. Right? Now, it can also be the case, right, that if X depends on Y, Y also depends on X. Right? And so you can have a two-way relationship, right? Dependency can work both ways. Right? So X depends on Y if Y shows up inside of your class somewhere. Right? So if it shows up as a field of X, if it shows up as a parameter to a constructor or method, if you have a constructor or method and it makes a local variable of type Y, or if your method returns an object of type Y, then X depends on Y. Right? Basically, if Y shows up anywhere inside your class X, there's a dependency relationship. Right? So on your UML class diagram, when you're describing the relationship between two classes, you can indicate a dependency relationship. Right? So we have our point2 class. Right? Now, point2 has a toString method. Right? So point2 depends on the string class. Right? So you indicate dependency by drawing a dashed arrow between the two classes. Right? Point2 depends on string. Right? Now, does string depend on point2? So if you look inside the string class doesn't know anything about the point2 class, right? Because we made the point2 class. Right? So string does not depend on point2. So there's no arrow going from string to point2. Right? If you've been reading the notes, the notebooks, you'll realize that there's another class called vector2 that works with the point2 class. Right? So it turns out point2 depends on vector2. Right? A point is a location in space. A vector is a direction, right? Or a direction with magnitude, sorry. So point2 depends on the vector2 class. If you look at the vector2 implementation, there's no mention of point2. So vector2 does not depend on point2. Right? Vector2 has a toString method, so vector2 depends on string. Right? Let's look at a Java standard library example. Right, so if you go and look in the object class, Java. Okay, so here's the documentation for the object class. We can't actually see the source code for it, so I'm just going to rely on the documentation. So here's our class object. Right, let's scroll through the documentation. Right, so here we see a method called clone. It returns a big O object. We have equals, takes in a big O object. Get class returns a instance of big C class. Right? So the class object depends on the class big C class. Right? Object has a toString method, so object also depends on the string method. Object depends on the string class. Right? And it looks like that's all. At least that's all we can infer from the documentation. If you click on string, notice that string, right? This thing here, these two lines of code here, are telling you that the string class inherits from the big O object class. Right? So string also depends on object. The relationship between string and object is actually much stronger than dependency, but it's still a dependency relationship. Right? And if you were to scroll through this class too, you can see the dependencies that string has. Right? String depends on this class called carset here, for example. Right? Anything else? Oh, here. Right? Here's a constructor that takes in something called a string buffer. So string also depends on the string buffer class. Notice that you don't care about primitive types, right? So here, string, there's a constructor that takes in an int, but we don't say that string depends on int, right? You don't care about the dependencies between primitive types and classes, right? You only care about the dependency between two or more classes. Okay, so that's dependency. Dependency is pretty straightforward, right? If your class uses another class, there's a dependency relationship. You can have a stronger form of dependency, which is called association, right? So in an association relationship, you have a has-a relationship. So what that means is that if your class X has a field of type Y, then you have an association relationship. Right? It can also be the case that Y has a field of type X, so association is allowed to be two-way as well. Right? X has an association with Y, Y has an association with X. Right? Both are legal. Oh yeah, so here's another example. I should really, what time is it, sorry? It's fine. If you want to show an association relationship between two classes, then you show that relationship using a solid line. So what this picture here is trying to tell you is the class ppm ASCII reader has an association relationship with simple image. Right? What this is really trying to tell you is that every ppm ASCII reader object has one simple image object. Right? So if you were to look at the implementation of this class, you would see one field whose type is simple image. Right? Again, I apologize for using this example that doesn't mean anything to you. Here's a much more complicated class diagram showing association relationships between several classes. Do I have time to just... All right, so I'm going to quickly describe this. I might go over this again in the next class. So this is a UML class diagram that shows that illustrates the relationship between objects in for example, a Broadway show or some kind of live performance. Right? So the show class, that represents the show. Right? The performer class represents performers in the show. Right? This line marked orchestra describes a role called orchestra between a show and a performer, right? So a performer that's in the orchestra, right, so plays an instrument for a show, right? So we have a show, right, can have, the star means 0 or more, right? So the show can have 0 or more performers who are part of the orchestra, right? A performer can belong to 0 or more shows as a member of the orchestra, right? And now you have the actors in the show, right? So a show, follow the line, right, can have 0 or more performers that are part of the cast, right? A performer, follow the line, can be part of 0 or more shows as part of the cast, right? So they can be an actor in 0 or more shows. A show can have 0 or more actors, right? Now, two performer objects can also have a relation, sorry, 2 or more performer objects can have a relationship with one another, right? So in the backup role for an actor, right, one actor or one performer, right, can be the understudy star. One actor can have 0 or more understudies underneath them, right? One actor, oops, sorry. One actor, oh, sorry. I have a stuck key. One actor can be the lead, can be in the lead role, right, of 0 or 1, what do they call it? 0 or 1 roles, right? So you can be the lead actor for 0 or 1 roles. Right? And so there's an example of a UML class diagram that shows many different association relationships. Right? All right, so we'll stop there. I think I'm going to go back over that. I'm pretty sure that last thing there I just described is somewhat incorrect. So we'll go back and fix that in the next lecture. All right, any questions about today's lecture? All right, so see you again on Friday morning.